Hello everyone. So in this session we are going to solve an important problem, that is the continuation of the previous problems. We have completed 3 problems, right, in 2 sessions. So in this session, one lengthy problem, we are going to solve only with this one problem in this session. So again, this is the given physical system here, as you can see. So the components here are M1, M2, K1, K2 and B1, B2, and also force is exerted in this direction, and due to force is exerted in this direction, we can see the displacement of M2, that is causing the displacement as x1 of t, and also M1 we can if we pull it in this direction, it is causing this displacement of x2 of t. Along with that, this K2, K1, B2, B1 are also getting pulled up. Okay. So first thing, let's write the equivalent mechanical network right now. So the first step we need to write is the equivalent mechanical network, right? Okay. So yeah, we have two displacements here, x1 of t and x2 of t. So represent them using nodes, x1 of t and x2 of t. So in this x1 of t, this force is exerted. So draw a force f of t along with the node x1 of t, and after that we can see that this m2 is also due to this displacement x1 of t. So again draw this m2 here, and this k2 is between these two displacements, right? So we need to draw k2 between these two displacements. And also we have B2 here. You can see this B2 also is between these two only. So we need to draw B2 in parallel. Again, this B2 is also between these two nodes only. And now consider this second node, that is x2 of t. What are all the components left here, left out? M1, K1 and B1. All of these are acquiring the displacement x2 of t. So all these three would be along the node x2 of t only, M1, K1 as well as B1. Okay. So this is your equivalent mechanical system. So now first thing we need to write is the equilibrium equations for these two nodes. So since we have two nodes, so we would be having two equations. One is at node 1. At node 1 we have this force, so write f of t first. This f of t is equal to, so what and all are the components here for this node? One is m2, so write m2 into d square, right? We have d square x by dt square, d square into displacement causing here is x1 of t divided by dt square, plus we have again b2, but b2 is between these two nodes, so we will write b2 into d x1 of t. First we need to consider x1, since we are writing equation for node 1, t by dt minus d x2 of t by dt, plus one more component is k2. This is also between these two nodes, again k2 into x1 of t minus x2 of t. Since for k2 we have along with that k2 we don't have any derivative. Okay, so it's only x1 of t and x2 of t. So this is the equilibrium equation for node 1 for the first displacement. Name it as equation 1. So similarly at node 2, since there is no force for the along with the x2 of t, so force is equal to 0. So what are all the components we have? M1 d square, displacement is x2 of t by dt square, plus b1 dx2 of t by dt, plus we also have b2, right? B2 is also attached to this node, but B2 is between x2 and x1, so we need to write B2 into d x2 of t. The displacement which we are considering, we need to write first that, and that we need to subtract with the other displacement, x1 of t by dt. Plus it's not done yet, we have still more components, right, left out. One is k1, and also this k2 is attached to this only node, so for plus k1 into x2 of t plus k2 again, and k2 is attached between these two nodes, so it would be x2 of t minus x1 of t. So this is your one more equation, equilibrium equation. So name it as equation 2. So these are the two equations for node 1 and node 2. So using these two equations, we are going to solve for FV analogy as well as FI analogy. So first let's solve for FV analogy. Consider equation 1. For equation 1, let's imply the FV analogy. So force is replaced by voltage, so write V of t is equal to, so M2 is replaced by L2 d square. The displacement is replaced by x2 is replaced by q2 by dt square, plus b2 is replaced by r2 d q1 by dt minus d q2 by dt plus k is replaced by 1 by c, so k2 is replaced by 1 by c2 q1 minus q2. Okay, so now let's solve this. L2 into, take d by dt common out, dq2 by dt plus r2 dq1 by dt minus dq2 by dt plus 1 by c2 q1 minus q2. So now V of t is equal to L2 into dq by dt is I, right? So since we have q2, so it would be di2 by dt plus r2 into I1 minus I2 plus 1 by c2 into, since we have q1, so q1 corresponds to integration of I1, right? q2 corresponds to integration of I2. So now for this equation you need to apply Laplace transform. So taking Laplace transform, V of t would be replaced by V of s, L2 and d by dt is replaced by s into I. Oh sorry, there is a correction here. This is not q2, okay? This is q1 everywhere. So this would be I1. So this is I1 of s. Okay. So please make this correction here. Plus R2 into I1 of s minus I2 of s plus 1 by C2 into, take this integration common outside, so it would be 1 by s I1 of s minus I2 of s. So this is your one equation. So name it as equation 3. Okay, so now consider for equation 2, apply FV analogy. So since we don't have any force that is equal to 0, so write it as 0 here. So M1 is replaced by L1 here, d square. Now it is q2 by dt square plus b1 is replaced by r1 dq2 by dt plus b2 is replaced by r2 dq2 by dt minus dq1 by dt plus k1 is replaced by 1 by c1 into q2 plus k2 is replaced by 1 by c2 q2 minus q1. Okay, so now let's solve this further. L1 into t by dt, take common out, dq2 by dt plus r1 dq2 by dt. So now replace dq by dt by I. So it would be d, since we have q2, so it would be di2 by dt plus r1 into I2 plus r2 into I2 minus I1 plus 1 by C1, since we have Q2, that's equal to integration of I2 plus 1 by C2 into integration of I2 minus integration of I1. Okay, so now for this apply the Laplace transform again. So this would be 0 only. L1 d by dt is replaced by S, I2 is replaced by I2 of S plus R1 into I2 of S plus R2 into I2 of S minus I1 of S plus 1 by C1, and integration is replaced by 1 by S, so 1 by C1S into I2 of S plus 1 by C2, and take this common integration out, so it would be 1 by S again, 1 by C2S I2 of S minus I1 of S. So this is one more equation after applying the Laplace transform. Name it as equation 4. So now using these two equations we are going to build the circuit for FI analogy. Okay. So here, since again we have two currents, so we will be having two loops in the circuit. So name those two loops as I1 of t and I2 of t. So in the first loop we have the voltage source here, V of t. Along with that we have two components in between the two loops, that is C2 and R2. If you observe the equations, so I have turned the page, so again I can't turn and show the page. So if you refer the video 1 minute before video, you can see the equations. Okay, so there are two components in between the two loops, that is C2 and R2. First I'll write those two components, C2 and R2. And in loop 1 we only have the component L2, and in loop 2 we have three components in series, that is L1, R1 and C1. Okay, L1, R1 and C1. I have not done this in detail, I have not explained it because we have solved already three problems and I have explained that in brief. Okay, so how this circuit comes, you can refer a previous video and you can understand this circuit. Okay, so yeah, this is the equivalent electric network for FI analogy. So now let's solve it for FI analogy. So FI analogy for equation 1, for equilibrium equation 1. So here force is replaced by current, so V of t, F of t is replaced by I of t. So M is replaced by C, so we have M2, so M2 is replaced by C2 d square phi 1 by dt square plus B2 is replaced by 1 by R2 d phi 1 by dt. So here displacement is replaced by phi. I am repeating it again and again, so you should not forget it. Okay, minus d phi 2 by dt plus 1 by L2 phi 1 minus phi 2. K is replaced by 1 by L. Okay, so further solve it. C2 into d by dt of d phi 1 by dt plus 1 by R2 d phi 1 by dt minus d phi 2 by dt plus 1 by L2 phi 1 minus phi 2. So again we know that d phi by dt is equal to V. So d by dt of phi 1, so we have V1 here plus 1 by R2 V1 minus V2 plus 1 by L2. Since we have only phi, so phi corresponds to integration of V. So phi 1 is equal to integration of V1 minus phi 2 is integration of V2. So now for this above equation we need to take the Laplace transform once again. So this would be I of S, C2 and d by dt is replaced by S, V1 is replaced by V1 of S plus 1 by R2 V1 of S minus V2 of S plus 1 by L2. So take this integration common, so it would be 1 by L2S into V1 of S minus V2 of S. So name this equation as equation 5, right? Yeah, equation 5. So now for equation 2, let's simplify. Since there is no force, so it would be equal to 0. M1 is replaced by C1 d square phi 2 by dt plus B1 is replaced by 1 by R1 d phi 2 by dt. B2 is replaced by 1 by R2 d phi 2 by dt minus d phi 1 by dt plus K1 is replaced by 1 by L1 into phi 2 plus K2 is replaced by 1 by L2 phi 2 minus phi 1. Okay, so now let's further solve this. So 0 C1 into d by dt, take common, d phi 2 by dt so now we know that d phi by dt is equal to V, so C1 d by dt, since we have phi 2 here, so it would be V2 plus 1 by R1 into V2 plus 1 by R2 V2 minus V1 plus 1 by L1 into phi 2, since that is equal to integration of V2 plus 1 by L2 into integration of V2 minus integration of V1. So now taking Laplace transform again, so this is 0 C1 d by dt is replaced by S into V2 of S plus 1 by R1 into V2 of S plus 1 by R2 into V2 of S minus V1 of S plus 1 by L1, and integration is replaced by 1 by S into V2 of S again plus 1 by L2, take common integration out, so that is again equal to 1 by S V2 of S minus V1 of S. So this is your one more equation for Laplace transform, name it as equation 6. So now using equation 5 and 6 we will be trying to build the circuit for FI analogy. Since we have two voltage sources, that is V1 of t and V2 of t, so first build two nodes, V1 of t and V2 of t. So compare the two equations, equation 5 and 6. So first see the equation 5, which and all are the components. Let's first see which and all are the components common for both the nodes. So common for both the nodes, the components are R2 and L2, right? Yeah, this is in equation 5. Let's see in equation 6 we have R2 and L2. Okay, so now let's write the common components between the two nodes, that is R2 and L2. So you would be asking why you are not written it in series in a one line. So we should not do that, students, because we have told you multiple times in FI analogy all the components must be parallel to each other. So whenever you are writing the components between the two nodes, also those two components also should be in parallel to each other. So this is a very important point to remember. Okay, R2 and L2. Okay, so now let's write rest of the components for first node, which and all are there. Here we have only C2, right? Yeah, so write C2, and also we have the current source, right? Yeah, name it as I of t, so this is C2. So now consider second node, that is V2. So which and all components are there? C1, R1 and L1. All the three must be in parallel to each other. Okay, R1, C1 and L1. Okay, R1, C1 L1. So this is your equivalent FI Anology electrical network. Okay, so we have built the circuits for it's visible, no, we have built the circuits for FI Anology as well as FV Anology here. Okay, so please refer these some students. These problems are very important, so please refer these problem students. So this kind of detailed explanation you won't be getting anywhere except our channel. So please like, share, subscribe, share this channel to a huge number of students. And if you are new to the video, please refer our previous videos in order to get the brief description of this concept, so you can understand the problems very clearly. So yeah, like, share, subscribe, and we would be meeting in the next video with few more problems which are pending. So yeah, that's all. Like, share, subscribe. Thank you.